So in this activity, you're going to find that there are some things that you're being asked to complete that you were asked to also do in the decimals activity. You're not completing the entire activity. You're completing all of page 1 and most of the second page. So for those of you that have the PDF copy as a bridge student or e-learning student, make sure you follow along with the video so you know exactly where to stop in the handout. So we're going to start looking at what's called the properties of the laws of logarithms. So one of the laws we're looking at is just another way of writing logarithm problems to be able to figure out the answers. So, for example, if I take the log of 10 to the third power, that's going to equal the exponent. If I do the log of 10 to the ninth power, the answer I'm going to get is 9. And the reason why is because if I would stick in the base here of 10, and if I would write this as an exponential, 10 to its exponent, which is 9, is equal to its answer, which is 10 to the 9th. So hopefully that when you look at that, it's like, oh, okay, that makes sense. So for example, the one above it, if I put in the base here of 10, it's going to be 10 to the exponent, which is 3. That's going to equal the answer, which is 10 to the third power. In the second rule, they're asking you to look at a different problem or rule. So this is saying that 10 to the log of some number like 3 is equal to 3. So if I was to write this as a log problem, it's going to be the log of my base, which is 10, to my answer, which is 3, and that's going to equal my exponent, which is log 3. So hopefully, again, you see that it's just kind of a fancy way of writing the log problem using some exponents. So if I would do 10 to the log of 5, that's going to equal 5. So if I would write that as a logarithm, it's going to be log of my base, which is 10, of my answer, which is 5, and that's going to equal the exponent, which is log 5. So what I'm getting is the same thing on both sides. So it says use this concept for the following. So what I'd like you to do is solve each of these problems based on the rule above. When you're finished, turn the video back on. So for the first problem, we're using, I'm going to call these Rule 1, Rule 2. For the first one, we're using Rule 1. So the answer to the problem is going to be the exponent. So log 10 to the 7th is going to equal 7 because if I put the base in here of 10, is 10 to the 7th, which is this number here, is equal to the answer, which is 10 to the 7th power. Problem 2, it's also rule number 1, and the answer would be just -3. In problem 3 and 4, I am using the second rule, and so here is that second part right here. So this ends up being log of 4. And then here, there's that second rule, so we're going to end up with log of 3.3. And because we are using a base 10 calculator for logarithms, we can stick the log of 4 in the calculator to see what that answer is. And the log of 4 is about 0.602. And the other one, the log of 3.3, is approximately 0.519. So again, anytime I can get the problem simplified so it's a log of something, some number, I can use my calculator to figure out that answer. Now, in these properties, we actually have talked about these two problems here in the Desmos activity. And we have a log of the number that we can break into two factors. We can rewrite that as a log of the two factors being added together. If it's a fraction, then we're subtracting the two numbers. Again, it's critical about the parentheses here, but when I have an exponent, we can actually pull the exponent out in front to figure out that answer. And so to kind of explain this rule here, why this works. So let's say I have a log of 3 to the second power. That would be the log of 3 times 3. If I go back to rule 1 here, I can separate that into log of 3 plus the log of 3. And since I have the same log, kind of like doing an x here and an x here, so I have the same log, I'm adding them together. It's like having two of those. So I could simplify this to 2 log 3. And that 2 is actually the exponent that we begin with. So for example, if I have log of 5 to the third power, I could separate that into log of 5 times 5 times 5. And then if I use that first rule, I can break that down to log of 5 plus the log of 5 plus the log of 5. And that would be like doing an x plus an x plus an x. So I can simplify that to 3 log 5s. And that 3 is actually the exponent from the original problem. So that's why that pulling that exponent of t out in front works, is because if I actually expand it all out and then simplify it, the number that's in front, which we're calling t right here, is actually the exponent in the original problem. As long as the base that we're using is the same number over and over again, like 5 cubed, 3 squared, 4 to the 5th. I could write log 4 to the 5th as 5 log of 4. If I expand this out, I'm going to have 5 log 4s added together, and that's going to be like having 5 x's. So they're asking you in these problems here to kind of use some of the rules to rewrite these as a single log. So you're kind of combining things. So they're asking you to use these 3 rules here to do that. So if you go ahead and complete 3 through 9, and then this is where we're stopping. So from here, for those of you that have the entire handout, we're stopping at problem number 9. When we're finished, turn the video back on, and we'll talk about the problems. So the first one is rule 1. We have an addition problem, so I can combine this as A times B. In problem 2, this is rule number 2 at the top, so I can combine the 2 logs as a fraction of x over y. In problem 3, it's actually a combination of both the first rule and the third rule. So this 3 is actually an exponent, and that 4 is actually also an exponent. So this could be written as log of x cubed plus log of y to the 4th. So that would be that first step, is to turn it back into an exponential part inside the parentheses. And then that's rule 3. And then rule 1 is because it's addition, we can combine it as a single multiplication problem. So it becomes log of x cubed multiplied to multiplied to y to the 4th. So the next one, we have 2 numbers up front. Those are exponents. So we're going to have log of a to the 4th minus log of b cubed minus log of c. That's the third rule. We have 2 subtraction problems, which tells me that these are going to be denominators. Keep in mind that in that rule, under subtraction, right here, in my subtraction, it actually ends up being a fraction. Because there's two subtraction problems, that means both the b and the c will actually be in the denominator. So the final answer here is log of a to the fourth over b cubed c. So a to the fourth stays in the numerator, the b cubed and c goes in the denominator because of the subtraction. If this would have been an addition problem, for example, so the plus, then the a and the b part would have stayed in the numerator, and because c is under the subtraction, then only the c would have gone to the denominator. In problems 5 through 7, they're asking you to rewrite these as the products and sums. So this, for example, we can rewrite this as rule number 2 as a subtraction problem. This problem here, again, I prefer the parentheses here. This one here, we could rewrite this as log of a plus log of b cubed. So the multiplication problem can be separated in addition. And because we have an exponent, we can pull that number, or that number, yes, out in front. So it becomes plus 3 times log b. Problem 7, we have the numerator, which is an addition, so it'll be x to the fourth plus log of b cubed. And then the denominator becomes subtraction, so it'll be minus log of c squared minus log of d to the sixth. So the a and b would be under addition, the c and d would be under subtraction because it's in the denominator. I'm going to leave the last part for you. Then you need to rewrite this so that the exponent is out in front. So if you go ahead and write that final answer. And then they're asking here for you to decide if these expressions are equivalent. And probably the best way to do that would be to simply, if you're not sure, just put them in the calculator, see if you get the same answers. Going back to problem 7, hopefully your final answer is 4 log of A plus 3 log of B minus 2 log of C minus 6 log of D. And again, this is where we'll stop.